Hello guys, my name is Momo Omotosha, and today we're going to continue with algebra, and we're going to be talking about solving inequalities. Now first, I guess we could talk about what is an inequality. And so far, we've just been talking about equations, which is basically, we were talking about the relationship between two sides of the equal sign, and hopefully the fact of all the values of both sides of the equal sign are true, and that's what gives you an equation. Now, an inequality is it's a similar sort of thing, but instead we don't have an equal sign. We have a greater than sign, a less than sign, all that sort of thing, where the two sides are not equal, they're unequal, hence inequality. So, yeah, today we're going to learn how to solve these when we have variables in our inequalities. So let's say we have the inequality 5x plus 7 is greater than 3 in parentheses x plus 1. So a lot of the things that are in this inequality we have seen before. We just have a greater than sign in this problem. So I guess we can take it step by step. And I'll first off just say that the way we solve equalities, or the way we solve equations is the same way we're going to solve inequalities. So we're going to try to combine like terms and that sort of thing. So first of all, we see this right here, and we know what this means. It means we're going to have to distribute this to each of the numbers and variables inside our parentheses. So let's do that real quick. I'm going to just write it out again so you can see what we're doing step by step. We have 5x plus 7x on the left side of the greater than sign, and then we have to distribute this 3 into each of these. So we're going to have 3 times x, and then we're also going to have 3 times 1, which is just positive 3. So now that we have distributed the 3, we can go ahead and start combining like terms. And now remember, I said that you kind of do it in the same way that you do it with an equation. So let's think about it like that. We have 5x plus 7 on this side, and we have 3x plus 7 or 3x plus 3 on the other side. So what I'd like to do is probably take away 3x from both sides so that we just have the x's on the left side. So if I do that, we have negative 3x on both sides. We have 5x minus 3x, which gives us positive 2x plus 7, which is greater than, we have 3x minus 3x, which is just 0, and we have positive 3. And again, we want to collect like terms, so we're probably going to want to take away 7 from both sides. So then we have 2x, positive 7 minus 7 is just 0, which is greater than 3 minus 7 is negative 4. Yeah. And so the final thing when we're solving for a variable is we want to divide by the coefficient in front of the variable. Since it's a 2, we're going to divide by 2 on both sides. So we have 2 divided by 2, which just gives us 1x, which is greater than, we have negative 4 over 2, which simplifies to just negative 2. So then this inequality is satisfied by any x greater than negative 2. So that means it's satisfied by 1, negative 1, negative 1, 0, 1, 2, 3. Anything bigger than negative 2 makes this equation inequality true. And in fact, let's just see that real quick. We have, let's say we say that x is 0, because 0 is bigger than negative 2. If we do x is 0, we have 5 times, I'm going to do a different color. We have 5, I'm just do black. 5 times 0, which is just 0, plus 7 is greater than 3. We have x equals 0 plus 1. So we have 5 times 0, which is 0, we said, plus 7, which is 7. And then on the right side, we have 0 plus 1, which is 1. So we have 3 times 1, which is 3. And 7 is indeed bigger than 3. So yes, trust me, and we did work it out anyways, that any x bigger than -2 works for this inequality. Now, we don't just have to have inequalities, or we just don't have to have one, I guess, or two sides to the inequalities. There can be multiple sides to an inequality. And it doesn't even have to just be less than, it doesn't have to be just less than or greater than. It could be less than or equal to. So let's say we have the inequality -16 is less than or equal to 3x plus 5, which is less than or equal to 20. So this is a bit longer. We have two inequalities, the same inequality, the less than or equal to operator. And we're going to solve this the exact same way we just did, but instead of doing it to both sides, we only had two sides in these cases. We have 3 sides in this problem. So we're going to have to do our operations to all 3 sides. So the first thing I want to do, or the first thing I notice, is that I see, okay, we only have our variable in the middle of this inequality. So if I want to get the variable by itself, we have a 5 here. We have a positive 5. And to get rid of that, we're going to have to subtract 5 from the left, the middle, and the right side. So if we do that, we're going to end up with -16 minus 5 on the left side, which is, again, I'm not the best at mental math. So 16, 17, 18, 19, 20, 21. We have -21 on the left side, which is less than or equal to 3x plus 5 minus 5, which is just 3x. The plus 5 and minus 5 just give plus 0, which is less than or equal to. And then we have 20 minus 5, which is just easy. It's 15. Okay. And one more thing. Again, we know that if we want to get the variable by itself and we have a coefficient, a number in front of the variable, all we have to do is divide by the coefficient. So let's divide by 3 every which way. Then we have -21 divided by 3, which is -7, sorry, which is less than or equal to 3x over 3. And 3 divided by 3 is 1, so we have 1x, or just x, which is less than or equal to 15 divided by 3, which is 5. And there you have it. We have that -7 is less than or equal to x, which is less than or equal to 5. And yeah, that is inequalities. So remember, we talked about how it's similar to solving an equation. We just do operations to both sides, or all 3 sides, or all 4 sides. Imagine if the inequality had it had 3 different operators. As many sides as we have, we do operations so that we get our variable by itself, and we solve for the inequality by getting the variable by itself, and we have a nice final solution like this. So thank you guys for watching. Hopefully you found it useful. And like I said, like I've been saying, we're going to continue on with algebra. So yeah, thank you for watching, and I'll see you in the next video.